Alright, hey guys, welcome back. This video is, I believe, the fourth video in a series we've been doing on charge and electricity. And I'm just kind of keeping it all under this one title for the sake of making an easier unit. This video is going to be really short. All we're going to do is how to find the cost of energy in terms of what you pay for electricity. I'm sure at some point you've had somebody talk to you about, don't leave that light on, yada, yada, yada. We're spending too much money and cost around here. So this is going to be like a three-step this is real easy. There's 3 steps to doing this. It's very repetitive, and it's an easy way of figuring out like what your electricity costs. So everybody's electric utility company, this was actually from 2009. This is interesting. I pulled up. I live in Alabama, and here was what our power cost circa 2009. It was 7 cents per kilowatt hour for your first 1,000. And this is in your summer months, and you notice then they penalize you for using too much electricity. The price jumps up 26 cents. Over here is the winter time. It starts at the 7 cents. And then the price actually goes down the more you use, because a lot of people in the wintertime use propane or wood heat, and so they supplement in other ways. So I think they're actually trying to promote you in the wintertime to use more electricity so you don't buy things like gas heaters. So anyway, this was in 2009, and I pulled this up. This is currently for where I live. It's still a $14.50 base charge. But then if you check it out, now it's actually 10 cents. It's went up 3 cents per kilowatt hour, which doesn't seem like a lot, but that's a 40% increase in rates over the last 11 years. So that's kind of interesting. They still... it's not going up too terribly much. It goes up, what, 0.003 cents as you keep going up for use. And so it goes down a little bit in the wintertime still. But anyway, so we're basically going to use 10 cents for my calculations today. So I've got 9 cents in here, but electricity just keeps costing more. So basically a dime per kilowatt hour. So step number 1, find your power usage. To find your power usage, all you have to do is do I times V. We talked about that in the last video, current times volts. Now, in the case of this problem, this computer tells me it's a 750 watt computer. So that means it's already told me my power consumption, 750 watts. But sometimes you'll see a plate on the back of an appliance, and like the plate will tell you that this appliance is 2 amps. Well, if it was a 2 amp appliance and you have it plugged into a 120 volt outlet, that means it's going to be using 240 watts of electricity. So that's an easy calculation to make. If we were in school right now, I'd send you home to find 10 objects in your house and actually try and calculate the power of those objects. But anyway, moving on. Step number 2. Determine the amount of energy delivered in kilowatt hours. So energy, all right, first off, where do I get this equation? It's the power, the basic power equation. Remember, power is work divided by time, and power is also energy divided by time. So that's where I get this equation. I'm going to switch colors. I've been writing in red for quite a while now, so let's go to blue. Let's say that energy is equal to power times time. So in this case, how much energy am I using? Well, I've got a power of what? Now I'm going to do something. The power company does everything in kilowatt hours. So I need to convert 750 watts to kilowatts. Well, there's 1,000 watts per kilowatt. So just divide. So that'd be 0.75 kilowatts is my power. If you're buzzing in the background, it's my phone going off. Times that by time. Now, this says the computer's left on all month without going to sleep. So my question to you is, how many hours are there? Let's say a 30-day month. How many hours are there in a 30-day month? Well, let's just try this real quick. 30 days times 24 hours a day, 720 hours in a month. So 720 hours. Now, no, this is weird. We never use kilowatts and hours in problems, but hey, that's the way your electrical utility functions. So let's try this. 720 times 0.75, there's my kilowatts, and that's 540 kilowatt hours. Again, normally in science we would find energy in joules, but this is not what Alabama Power uses. Now the last thing is just to determine the cost. So step number 3, to find the cost of your appliance, you take your energy and you multiply it by your price. So in this case, it's going to be really easy using the dime. Maybe that's why they went up on the cost of electricity. Easier calculations. 540 kilowatt hours times the cost of electricity is, where I live, 10 cents. If you live in California, it's probably much higher than this. I'd be curious to know. Somebody could post in a comment what that cost is. It's actually that much. So that's your cost, and my computer's trying to fail. Don't do it. I'm almost done with this video. Per kilowatt hour, it's that many dollars per kilowatt hour. So wow, $54 per kilowatt hour is my cost. So fortunately, this is, but what's funny is, used to be high schools in particular, they would let these big computers run 24 hours a day. They never went to sleep, and you could quickly see what that could do to a power bill. So you also now know why the sleep function was added to computers, to try and cut down on that power consumption. Plus, like modern laptops and things most of us use, they don't use 750 watts. But you could easily go back here. Call this your homework assignment. If you had a traditional 100-watt light bulb on your front porch, why don't you try and do this? If you were to leave that on every night, all night long, let's say 12 hours a night, figure out, step 3, figure out your cost. Things like that. This is good stuff for you to know what you're paying for your electricity. Anyway, thanks for watching, and we'll catch you later.